Hello everybody. In this spreadsheet tutorial we're going to go over the BINOMDIST function, and you can think of the BINOMDIST as being short for binomial distribution. So let's go over the binomial distribution just a little bit before we get started. Binomial distribution is the probability model for counting successes. Examples include shooting 10 free throws, and how many did you make, planting 10 plants, how many lived, and how many patients recovered after a treatment. The criteria for binomial distribution includes a fixed number of observations. Observations are independent. So for example, the first coin toss tells you nothing about the second. Each observation is a success or failure, and that's why it's called binomial. Bi for 2, there are 2 outcomes, success or failure. And the probability of success is the same for each observation. There are 2 main parts of binomial distribution. N, which is the fixed number of observations, and P, which is the probability of success. So let's go over the BINOMDIST function just a little bit. It takes 4 arguments: the success number, the trials, the probability of success, and the form type. The success number is a number value representing the number of successful trials or tests. The trials is a number value representing the total number of trials or tests. The probability success is a number value representing the probability of success for each trial or test. And there are 2 form types, cumulative and probability mass. And we'll go over examples of each of those. Let's move on to our first example. If 20% of all automobiles in a large city are foreign made, find the probability that if there are 8 automobiles in a parking lot, 3 are foreign made. So as we mentioned before, there are 4 arguments: success number, trials, probability of success, and form type. So all we have to do is take the text of our statement or challenge here and plug it into our formula. So the 20% would go here, and we put that in as a 0.2. The 8 automobiles would go here for the trial or N numbers, and the 3 are foreign made would go here for the success number. And we will use the false or 0 probability mass form type in this case because we want to find the answer for the specified number of successes. If you wanted to find the answer for a series or a summation of successes, you would use the cumulative. But in this case, we're going to use the probability mass form. So let's go over the BINOMDIST function. And you can see we have just plugged in our numbers into each argument. So the first argument, the success number, we put the 3. The second argument, the trials, we put the 8. The third argument, the probability success, we put 0.2 or 20%, and we put 0 for the probability mass form. And you can see you get an answer of 0.1468, or as a percentage, about 14.68%. Now if you wanted to see this visually, we have a graph here, and we use the BINOMDIST function to find the probability of success for each individual number of successes. And you can see here for 3, this is the example we used. We got 0.1468. And that would be on a graph right here. And if you wanted to see the outcomes for the other probabilities of success numbers, you can see it graphed in this graph here. Okay, moving on to example number 2. If 70% of all homes in the U.S. have at least 1 pet, find the probability that if there are 9 homes surveyed, all 9 have a pet. So again, we've gone ahead and we've taken our text here, our challenge, and just plugged in the numbers from our statement into our arguments. So the success numbers is 9, and the trials is also 9. The probability of success is 0.7 or 70, and we're using form type 0 again. So we just plug those numbers in to our BINOMDIST function. 9, the success numbers, goes for the first argument. 9 for the trials goes for the second argument. Probability of success 0.7 or 70% goes for the third argument, and 0 for the form type. And you can see we get 0.0404, or about 4%. Moving on to example number 3, if 70% of all homes in the U.S. have at least 1 pet, find the probability that if there are 9 homes surveyed, 4 or less homes have a pet. So the main difference in this example is this part right here. 4 or less homes have a pet. So this is where we would want to use the cumulative form, and for the last argument for the form type, we would put true or 1. Okay? So we just plugged in our numbers into our formula. The first argument, success numbers, is 4. The second argument, trials, is 9. The probability of success is 0.7 or 70%. And for the last argument, form type, we put 1 for cumulative. And we get an answer of 0.098, or about 10%. For our last example, let's change that to a 4. Example number 4. If 70% of all homes in the U.S. have at least 1 pet, find the probability that if there are 9 homes surveyed, 6 or more homes have pets. pets. So you can see this one is similar to example number 3, but there's something in this example we're going to do that's a little bit different. Okay, so again, we take our statement, we plug the numbers in from the statement in for our arguments that we want. So the success numbers would actually be 5, and that might seem a little bit counterintuitive at first, but we'll explain that here in just a minute. Our trials is 9, our probability of success is 0.7 or 70%, and we're using the cumulative form type. Okay, so what we want to do is we want to create our function the same way we always do and plug in our arguments. Okay, so what this will do is it will give us the cumulative answer for the probabilities of success for the numbers 0 through 5, and we want the cumulative effect for 6 or more, so that would be 6, 7, 8, and 9. And in order to do that, we get the BINOMDIST for 0 through 5, and then we just simply put a 1 in front and subtract, and that will give us the cumulative probability of successes for 6 or more homes who have pets. Okay? And our answer is 0.7297, or about 73%. That's all we have for this spreadsheet tutorial on the BINOMDIST function. We will be doing many more spreadsheet tutorials in the near future. Join us for those, and we'll see you next time.